My name is Katie Musick, and I did my case study on Mill Creek. Creek is located mainly in Jackson and Wood County, flowing through the city of Ripley, West Virginia mainly. The stream is about 29 miles long with a drainage area located in Millwood of 608 kilometers square, and the stream is also a warm water stream. The watershed that Mills Creek is located in is the Middle Ohio South watershed, and the types of land uses we have here are mainly deciduous forest, which is about 71%, industrial and agricultural, and there's a low residential area just because of the mountainous topography that we have. And as you can see with the point sources and non-point sources, that really explains the land uses there, because for point sources we have in Ripley the wastewater treatment plant that's there, there's a lot of package plants and stormwater construction going on. And for non-point sources, since there is urban areas, we get a lot of storm water runoff and agricultural lands from small farming that we have in the area. This is according to the West Virginia Department of Environmental Protection. Mills Creek is a Category 4A because it does not support for public drinking, recreational use, or aquatic life, due to one or more of the contaminants impairing the stream. As you can see on the slide, the designated uses that are required by the West Virginia Department of Environmental Protection are on there, and Mills Creek does not support any of them. So why is this stream on the 303D list? And it's because of the parameters of the high levels of fecal coliform, iron, and conditions not allowable for the biological stress of aquatic life, specifically organic enrichment and sedimentation. And all these parameters are impaired for the entire length of Mills Creek, which is 29.4 miles long. To calculate TMDL, we must add up the sum of the waste allocation plus load allocation plus margin of safety. So, for example, with daily fecal coliform, we take the baseline allocations, which are the current levels of the stream, and compare that to the wastewater allocations, which are the point sources, and the load allocations, which are the non-point sources, and then add that up to the margin of safety, which is 5% between the range of the contaminant to receive the TMDL counts per day. Iron is calculated the exact same way, except that we use pounds per day instead. For the biological stressors of the organic enrichment and sedimentation, the overall stressors was given a 67.8, which was provided by the West Virginia Department of Environmental Protection, and this is not necessarily, it's still impaired, but it's more of a risk zone now rather than completely impaired according to their scale. The method for collecting the data for the TMDL is both for iron and fecal coliform. They're the exact same with a grab sample, except there's a different method how you collect it. For fecal coliform, we use a pre-sterilized bottle with a tablet of sodium thiosulfate, and you pack it with ice, and it needs to be held on with ice for 12 hours, and then it can be analyzed through the lab. With iron, however, you take a bottle and treat it with nitric acid, and so that can have a pH less than 2, and then it can be tested as well. For biological stressors is different, as you can collect microinvertebrates or insects in different points of the streams where you sampled your iron and fecal coliform. You can do that as well to understand the habitat's richness. This is based off the whiskey scores, which states that the stream below 68 is impaired, and between 68 and 78 is referred as the gray zone. 69 and above is a biologically well-ordered stream. strategy for fecal coliform is to reduce the amount of untreated sewage discharge by removing such things as straight pipes and failing septics, which is required by the West Virginia Bureau for Public Health anyway. Another strategy is to reduce the combined sewage overflows in the MS4 to their criterion value that they must have. And this can be hard because there is an urban area and an industrial area. So when stormwater happens, it can overflow and that can cause it. But if there's a way to lower these values, it would be great. For iron, the strategy is to reduce the abandoned mine lands disturbance areas, because they find in a lot of places where there is abandoned mine lands, a lot of the trees are disturbed and removed from the area, which is causing a lot of bank erosion where the sedimentation is going into the water, and that causes a lot of higher iron in the land. If there's an active mining site near the stream, a permit's required if you're exceeding the limit of iron, and it must be lowered, and they must lower the iron levels or fines will be given. For biological stressors, however, the only strategy is to reduce the iron in fecal coliform to get rid of it. The West C score of this watershed was given a 62.61 near Berkeley, West Virginia. And the West Virginia Department of Environmental Protection gave the biological stressor average to be 67.8, which means that this watershed is impaired, but if worked on, it can be stabilized and these parameters can be lowered into the right criterion value. Mainly this score comes from pollution and the human disturbance that is met with this area through the land uses of industrial and urban areas and agriculture as well. And as you can see in this picture, the bank stability is there's a lot of bank erosion in this area, and this is mainly because of the removal of trees, because the roots stabilize the bank so it won't move when the river starts to meander. But there is, however, a lot of riparian vegetation, as you can see with the trees and the shrubs. So that's good, because that shows that there is habitat for like species and stuff. There is another good thing, which is the large woody debris in the area. If you can see in this picture in the very back, you can see some of the large woody debris back there. And this provides habitat and shelter for the stream and for the area as well, for the fish and for the area. The water quality shows the high iron levels, which isn't good, because for the toxicity of aquatic life, especially for fishes, they can only handle 1.5 milligrams per liter of iron in the streams. So this causes high toxicity for the aquatic life, which isn't good, and for the health of overall the watershed. And as I said earlier, the urban and the industrial area causes a lot of runoff into the streams, causing a high sedimentation level and providing high metals. Because, for example, let's say we're at an industrial area and the equipment is just laying out. When the rain hits, all the metals that will leach into the soil or will run off into the stream, and that causes that high sedimentation. Another thing about the watershed overall is that there's a high trash index, according to some locals I talked to, and they're mainly tires and plastic bags are the main source of trash pollution in that area. So overall, I believe what the West Virginia Department of Education says, that this stream is healthy to an extent, but it's impaired obviously, and if these problems aren't fixed, overall the stream will soon decrease. For the types of NRE NPS permits in Mill Creek, I found that there were 11 individual general permits for sewage facilities, 28 package plant general permits for stormwater construction, and 19 industrial permits that were individual for groundwater remediation. The general stormwater constructions for the major contaminants are iron, fuel, and just other sediments. The source of these contaminants is mainly surface runoff. The monitoring regimen is every week to inspect the erosion control within 24 hours of a storm. For general stormwater industrial, the major contaminants are toxic chemicals, fuels such as and fuel metals such as aluminum or copper, because that can really impact the aquatic life that you have. For the source of this contaminant is like the unsheltered equipment, metals that are there, oil from storage tanks. So the monitoring regimen is to inspect the equipment weekly, keep equipment in safer areas, and put fuel in different storage tanks or different storage areas where they're not exposed to the stream adaptation. And then for sewage, general permits is major contaminant is fecal coliform, and that's just from raw sewage, from just use in the bathroom. And the monitoring regimen here is for monthly fecal coliform grab as the method I explained earlier. So that way the levels are maintained of the geometric mean of 200 counts per milliliter. And just an inspection of the equipment, make sure nothing is not working like yeah. So I wanted to go into a little further of just the NPDES permits that I was looking at, and one of them was the Ripley wastewater treatment plant, and the contaminants they have were fecal coliform, grease, and just other discharges, and they were violating their exceedance limit, and that was stated in the West Virginia Code of 22-11-15, and that there's no exceeding your limits or you'll be fined. Basically, that was what that code was saying. And the storm on the next permit that I have here of the conference center, that was a stormwater construction because they were having a lot of trouble with their groundwater and like it mixing, from my understanding. So the contaminant here was fecal coliform just from the raw sewage that was happening, and so they also violated the exceeding discharge limit. And so then I thought, well, I probably should find something that's not exceeding its limit but it's close to it, I feel like, personally, and that was a leveling off a baseball field. That the contaminants there are high sedimentation of metals that will erode into the bank as they're leveling off. Bank erosion will happen, and so other metals will go into the stream, such as iron and possibly aluminum, but they have no standing violations yet. And then here is the word cited. Thank you.